This workshop is going to go through several aspects of leveraging Oracle Analytics Cloud with ADWC. First, let's connect OAC to ADWC. We start by creating a new data set within OAC, and because it is the first time we're using our ADWC, we have to create a connection to it first. The connection wizard prompts us with several information. We can get that information from the wallet file that we downloaded from ADWC. For this, we unzip it and we open the tsnames.ora file. Within that file, we will find server information, service name information, and port number information. They are highlighted in this video. So we need that, copy that information, and paste it back in the wizard. We need to point to the cwallet SSO file that was part of the wallet zip and provide with the credentials to access this database. As we click Save, the connection gets created and we can see all the schemas that we have access to for this database. I can look for the demo data that we are using in this demo, DCA sales data, add the table, and select all the columns to be added in the OAC dataset. As I add this dataset, it gets created into OAC, and I can now start to prepare my data within OAC. Let's adjust the dataset property briefly. So we are going to hide the recommendation pane for now and just focus on simple preparation, like we would like customer ID to be an attribute, not a metric. We are going to use the loyalty ID to count our customer using a count distinct aggregation. And let's rename this to be number of customers so that when we use it in reports, it's more meaningful. Finally, let's also extract some date format from detailed sales date. Let's extract the week because we will want to report at the week level. There are other ways to do this in OAC, but let's illustrate this preparation capability. Let me rename this to be sales week as well. So we are done with our basic preparation steps here, and we can see them all listed in the preparation script on the left. Let me apply script so that this metadata gets pushed down to our data set, and we can go ahead and create a project to get immediate insights on the data. So at this point, we could start building visualization and getting insight by dragging and dropping columns into the canvas. But instead of doing this, we're going to start by using the explain feature. We will explain value, and explain will return several charts and analysis on the distribution of this metric value across different dimensions in the dataset. So we can see how value distributes in general and per each dimension. We can simply click on several charts to retain them in our canvas, in our project, because we're interested in them. The anomalies tab shows us where the system found out that values of the metric were different than what it would have expected given the distribution across different dimensions. This is leveraging some ML algorithm behind the scenes. Similarly, I can add some charts to my canvas, and when I click Add Selected, I can see all the charts being added to my canvas here. I can run explain on metrics and on attributes. So if I visit explain for subcategory, for instance, I will see similar distribution information about the subcategory column, along with several sets of information such as key drivers, segments explaining the subcategory, or anomalies. These are all being results of ML algorithm running behind the scenes. Let's exit explain, and let's go try another cool interface of OAC that allows us to ask direct English questions to our dataset. To enable this, we need to flag the dataset to be queryable by voice. This is done under the search index panel here. Search lets us configure exactly what we want to be searchable. Is it column names, or is it data, or both? What language it is in, and how frequently we want to schedule the refresh. The default process will run every 2 minutes on the system. So within 2 minutes, this data will be indexed. You can use this time to visit the other tabs about permissioning or editing data element properties, all under the inspect menu. Okay, so let's hope for the indexing to be complete at this point, and let's now go and query our data in English. And we go to the home page. There is this dialog bar at the top where we can simply type English questions, and the system will parse this question, recognize data elements, figure out which data set serves them best, and return type of visualization that better answer these questions. For instance, we can already see that the blue line, number of customers, is going down. We're losing customers, and that's a concern. We could filter this for a single channel by typing the value of that channel, direct, for example, or we could just simply ask by channel. The system will automatically parse our phrases and interpret their questions and return the most appropriate charts. So let's now go visit another media for asking questions to our data, which is mobile phone. we can download Oracle Day-by-Day application on both Android and iOS. And once downloaded, open the application. Just type in the server name that we're using, just simply the server name, hit connect, and just log in, providing our login password to OAC. We can now simply speak questions directly to our dataset.
Show me value by week and customers by channel.
The exact same process happens. Questions are being parsed and reports are being returned that best matches the question based on the best matching data set for these questions. User can visualize all of these cards and pick the ones that he likes the most. He can also add them to his daily feed, and it will be returned on a given frequency or based on a specific location. Or he can also share with his team and comment with specific questions. So users can easily collaborate this way. Okay, let's now return to the browser version of our workshop. We need to get much deeper insight about this issue on losing customers. So we're interested in one of the visualizations that was returned to us by the dialog here. We're going to click on it and open in data visualization. There, I can see the data set on the left, DCA sales data, as well as the grammar pane where I can drag and drop columns to slice data. Let me drag category to become a trellis column. And I can now see the breakdown by product line and by channel. And clearly mobile phone seems to be the area where we consistently lose customers over the past few weeks. Let's add a trend line to all these charts. We right-click and choose trend line in the right-click menu. The system automatically populates each cell with a trend line, and we can see that mobile phone is the one with the strongest downward trend. We can modify properties of the visualization of the trend line. We can change the type of line. We can change several properties of the chart. So now let's add a right-clicked forecast as well to all these charts. So this will compile historical data per intersection and provide with forecast information. This will take a little longer to run, and it returns a forecast value based on an ARIMA model. We can see here as well that the mobile phone is the area where the forecast is the most negative. Let's turn off that forecast before we move on. And let's go and look at monitoring what's going on the data warehouse side generated by the analysis we're launching on OAC. So for this, we're going to navigate back to our cloud console, go to our data warehouse, and from that data warehouse, open the service console. That service console is, so we have to log in with our username, and that's where we're going to be able to monitor the activity of our data warehouse. We can see all the SQLs going on here. Well, see if I go back to OAC, refresh my query by clicking refresh data on the main menu. If I go back to my console, in my case, I will see that nothing has happened. Most likely it'll be the same for you, although many other users may be using your ADWC. Why is that? Well, if I go in the inspect tab of my dataset, I will see that the default configuration is automatic caching for the dataset, which means that OAC figured out that our dataset was small enough and downloaded it locally. So let's set this to live instead. So that will fire up direct queries to the data source every time we refresh. Now let's refresh the data and check the console again. Let's make sure we refresh console, and now we can see the queries being fired by OAC to the ADWC instance. Notice the degree of parallelism being set to 4 here in our example. Now let's suppose that we have longer running queries as a result of our analysis. Let's mimic this. Let me turn off the automatic refresh of OAC, and then let me build an analysis that could run a little slower. Add a metric, for instance, and then replace sales week by day of year, for instance. So this is still going to return pretty fast, given that we only have demo data, but it should run longer than just a second. Let me hit refresh, and it's taking about 5 seconds to return. Let me go and check the ADWC activity log, and we will see a query that runs for about 4 seconds. Let's pretend that this is too slow for us, and we're checking we only have a DOP parallelism of 4. So let's scale up ADWC. So if we go back to our console for ADWC, we can click the scale up button. There we can scale up the number of CPUs from 4 to 16, and we could do this for storage as well. If we click OK, then the system goes now in a scaling in progress mode for about a minute and a half. Notice that while this is going on, I can still go on OAC and hit queries and use the ADWC. It will scale up seamlessly. It won't interrupt my activities. Within about 90 seconds, I can see that this is back to available. Let me go back to my OAC and refresh this one more time and see how long it takes in the system from the initial 3.26 seconds. We're now down to 182 seconds. So we've clearly improved the performance here, and it's using a parallelism of 16. Note that the scaling up, scaling down task could also have been done via APIs, and it happens completely seamlessly. Now let us take a few seconds to see how we can see the OAC query logs to check the physical queries that are being generated by OAC in case we needed this for troubleshooting. If I go in the main menu and go to the console tab, there I have lots of administration choices, including monitoring, session, and query cache. This will present me with a simplified version of the logs of all the queries being fired by OAC, which I can sort by time descending. And here is one query here, and I could ask for view log. So what I see here is the logical SQL, which is language of OAC. But if I scroll down, I will see the direct physical SQL that was sent to the source database. This is useful quick navigation when one needs to check how the underlying database was hit and if cache was hit. Let's go back to our project here, which we had saved previously, and build initial interactive analysis to continue drilling into our issue of customers leaving from a mobile phone. So let me duplicate the canvas so I keep a copy of this. I will rename the initial canvas. I will call it quadrant, for instance, and now I can go to my copy and select only mobile phones, for instance. If I right click on the word mobile phone and say keep selected, this will filter only. You can see at the top the filter value has appeared for mobile phone. Now let me drag channel from being rows to becoming colors, and let's turn off trend lines as we don't need them anymore. And let's drill on the direct channel. That's where we have our issue. Let me right click on the word direct on the legend and say drill. And this prompts me with what level of detail I want to drill into, and let's select subcategory, which is a product subcategory, and see what happens. We can see right away that not all the products behave the same in terms of number of customers, and I can see that Android phones and other accessories here have pretty different behavior. Another way for me to have done this is, let me go back and undo what I just did. And instead of drilling like I showed a minute ago, I'm going to build a different chart with subcategories and number of customers. So that's going to be a donut chart. So let me create it. Let me move this so that it looks better on the screen. Notice that I can easily change this chart type back to whatever I wanted, like a tree map, for instance, or going back. Let me edit the properties of this chart so we can see number and values. I can ask for %n labels. And now let's turn on this donut chart to become a filter to everything else on the dashboard. So let me click on Use as Filter. And as I now click on every value, the line chart updates just for that value. So I can see, for instance, that jackets and covers are gaining customers. But if we click on phones, we're losing customers. So not every product behaves the same. So let's keep a track of this canvas and duplicate it and rename it. Let's give it the name of phones, for example. In the copy, the new copy of the canvas, let's go ahead and manually filter for the subcategories Android phones and iOS phones, since we've discovered these were the issue. And let's retain only direct channel. So we can do this by just dragging and dropping columns and clicking on the values we're interested in. So now that we have identified product and channel with the issue, let's profile the customers who we're losing. For this, we're going to mash up an extra data set with customer demographics. To add the data set, let me go on the top left, Add Dataset menu, create a data set because it doesn't exist, select the connection that we created earlier, and then select the schema where the data set is. In our example, it'll be DCA customers data. So we click on the table, add all the columns, and then add the data set. Note that we could have added a data set from any other source or file or any other database. So the data is getting profiled, and what I can see here on the right is a set of recommendations about transformation on my data. So it suggests, for instance, to enrich the CT column with several extra information like jurisdiction or population, All I have to do is click on the step and the population is incremented in my data set, and I can see the column right there. I can do all sorts of other transformation that are right-click away, like grouping, for instance. Let me create groups in my income level. So I'll create a group below 70, and I will select only the values that I want in this group, and then a group from 70 to 150, and I'll select all the values that I want in this group, actually 130, and then another group at the end with everything else. So I'll just add all. So instead of my income level detailed information, I will now have an income group column in my data set that groups these values. At this point, I'm happy with these changes. I'm going to apply the transformation script. And before we go on to building visualization, let's visit the data diagram pane. So here we can see that the two data sets have been automatically joined by a single column customer ID that was recognized by the system with the same name and the same type in both data sets. I can easily extend this joining with more matching or tune the properties of this join to be a fact-to-fact or a fact-to-dimension join. Let's pick dimension here. So we're done. This was automatically recognized. We're ready to go and visualize the mashup data in our visualizations. So let's go on and profile our customers using geographical maps visualization and several other features of Oracle DB. We can see the new data set now being part of the data elements on the left. We can expand and see all the objects right there. So let's clean up our canvas for a minute here. Let me delete that donut visual first. And let's also remove that filter subcategory that was added to the line visualization. Let's also remove the category out of trellis columns because there is only one category. And now let's replace that channel object by marital status coming from the customer table we just added. Well, we're losing customers across all marital status. It's pretty visible. So let me pick another attribute here like age and replace marital status by age. And that gives a pretty busy visualization, and not all age classes are behaving the same. This is too busy. We need to group this and bin it. So let's add a calculation, and let's add age bin calculation. And for this, there are pre-built formulas in OAC like bin. I can search for bin that will let me do this. So all I need is the column age. That's what I'm binning. I don't need any by clauses. And I'm just going to say bin age into 6 bins. And I don't want the bin number returned, but instead I want the range low, the lower age for each bin. So all I do is copy this, bin age into 6 bins, returning range low. Validate this, it works, I have the right syntax, hit save, and here's my calculation. Let me replace age by age bin. And now clearly I can see that one age bin in particular, people between 45 and 60 years old, is the place where we have the highest attrition. So that's pretty important marketing information. Now if I qualify this by gender, I can see that this is mostly happening for male customers. And let's slice this by income group as well. That's the object we prepared. And we can clearly see that the male between 45 and 60 with a high income group are the ones that we're losing. So let's rapidly add this income group as a filter here, over 130. And now let's add a geographical map visualization to this canvas. So we're going to pick state and number of customers and create a map visualization. And by default, this will select the right map layer and show us a map of the US with the number of customers as color. We can use this as a filter. And as we click on different states like California, the next visualization will filter and we will see that we're losing customers and how many in this region. I can also multi-select for several states and this will filter for several states. So let me return to California and let's now rename this canvas and call it demographics. Let's also duplicate it so we can carry on the work. What we're going to try to do next is to share this information with marketing. So for this, let me just filter just on male gender because that's the interest here. And let's go on and see how we can share this and also build some narration on this set of dashboards that we build. Let me reorganize my dashboard and let me create a table with lots of customer demographic information that I would want to export and share with marketing. So I'm going to build a table and here's a list of names and customer IDs. Let me reorganize this briefly. And now let us filter just for one state using the map. So let's click on Florida, for instance. Let's say that we want to export the contacts for Florida. And here's the list. I select that view and I go to the Share pane and click on Sharing Data itself as a CSV format. And as I do this, I download the CSV data of that visualization, which if I open, I can easily share it. It has all the details of all the male customers in that region, for that age range, for that income group. To present these results, we could have exported as PowerPoint or used the narrate function here. And narrate allows us to organize the canvases into a story here, put comments, format things, highlight things, and then go into a presentation mode. So when I go to presentation mode, most of the features of the interaction features remain, but I have a story to tell, and I go in a presentation way about my story. In the last part of this demo, we're now going to leverage the machine learning notebooks capability of ADWC to enrich our marketing analysis with predictive information and models. So let's switch back to ADWC console. Let me go to menu and go to the service console of my data warehouse. So just selecting my data warehouse, clicking on the right menu here, service console. I'll have to log in. And there is an administration tab under which I will find manage Oracle ML user. So the first login will have to be with admin user, admin rights, to create a normal user. So in this case, we have created demo user already. You may need to create one on your side. Then click on the home to get into the machine learning console with the normal user, demo user, and you get to this page. So in this demo, we're going to use out-of-the-box vanilla examples that come with ADWC. And in particular, we're going to leverage a classification prediction model just for the sake of the example. And this model scores each customer with a propensity to subscribe to a loyalty card. And the data set used by this model is actually the same as the one that sourced our own demo model. So we can review all the steps in the notebook. We could obviously customize this, but we'll leave it vanilla for the sake of this demo. So we're going to use this, but to be able to use it, we need to first export it out of the example set. So we'll export this and import it back into our own notebooks. So let's do this. Let's go to notebooks. Let's click on import, point to the file that we just exported. It's a JSON file, and it will create the notebook for us. Here it is. So we can simply open it and run it. Obviously, in real life, tuning such a notebook would be a lot more complex. We're just using one that has been ready. Okay, so let's click OK, and the notebook is running. The model gets created, and the data set gets scored, and a result set table is being created as well in the database. So all we have to do at this point is go back to ADWC and blend the result sets of that notebook ML by adding a data set in our project. So let's go back and create a data set. Go to our connection and look for demo user schema right there. And within that demo user schema, we're looking for result data set, apply result, for instance, or lift tables. Let's briefly bring these two. Let's start by apply result. So these are customer ID and the prediction and the probability. Let's rename this. And let's add it as a data set. And let's just briefly make sure that the customer ID here is an attribute and not a metric. And let's review the aggregation rule for the prediction and the probability. So that's a measure, that's an attribute actually, and the probability is an average, not a sum. All right, that's it. We can apply the script and build visualization. The joining is been done with both our fact and dimension data through the customer ID column, so that's correct. So now we can create a new tab. We duplicate the existing tab. We can shuffle around a little bit the visualization here. So we don't need this and we don't need this. We just want to look at the population that we have created earlier on and drag along the scoring and the probability. So prediction of positive response to an affinity card and the probability for this. There we go. You could see the prediction in the middle and the probability. So 0 or 1, basically both predictions. So we want to filter only for the ones that respond positively to our offer. So we can sort the probability by from high to low, and we can see the most probable to accept an affinity card here, which could be a marketing action that we could take at this point. Another way to leverage this information would be to visualize it for the group that we've identified earlier on. So let's look at the average probability by age to start with, for a prediction of 1. And that's interesting. But now let's break this down by income group as we did earlier, and then gender. So we can see that higher income groups have a higher propensity, which is good. And male higher income groups have a higher propensity as well. Let me just filter out the null and exclude the null values for gender. And we can see that the bottom right corner here has a pretty high propensity. Let me put customer number as a metric for color. That will be a good indication of the size of our target population. So this visualization is pretty interesting for our marketing team. Now, one more way to leverage the results of the ML notebook is to create yet another data set using the lift table results. So let's go to lift, add lift table as a data source. Let's add all. But lift table does not have information about customer ID, so it's not going to join to the existing data sets. It has quintile number, so let's make this be an attribute, not a metric. And let's apply the script. And let's visualize this. So this data set will come out as a non-joined data set within our project. So you can see it is below a threshold right there, and it cannot be combined with other data set, but we can build visualizations in the same page. So let's take a line with quantile and gain of cumulative gains of this model, and we can see the lift curve right there. We can have the lift cumulative here as a Y2 axis and build these charts leveraging results of the ML model. So this concludes this demo. Thanks for your interest and your time watching this.